So welcome back Python enthusiasts. In this video, we are diving into the exciting world of data structures. Specifically, we will be exploring one of the most fundamental as well as the versatile structures, the linked list. So if you are ready to take your Python skills to the next level, let's get started with the following agenda: introduction, definition and purpose, basic terminology followed by the values, types of linked list, implementation, advantages as well as the disadvantages, and last but not the least, use cases and application. Introducing linked list. The linked list is a fundamental data structure used in computer science and programming. It is a linear data structure that consists of a sequence of nodes where each node contains a value and a reference to the next node. Purpose of the linked list is it provides an efficient way to store and manipulate data dynamically. They allow for dynamic memory allocation and can grow or shrink as needed. The definition of linked list is as follows. A linked list is a data structure in which each node contains a value and a reference to the next node in the sequence. Linked lists are used when the size of the data is not known in advance or when efficient insertion and deletions are required. They provide flexibility in memory allocation and allow for efficient manipulation of elements. There are some basic terminologies in the linked list we need to look at. First one is node. The second one is the pointer. Third one is the head. And the last but not the least are tail. Talking about these all terminologies. So, as we all know, the linked list is composed of nodes where each node contains a data and a reference to the next node in the list. These references are known as the node pointers. The node pointers plays a crucial role in maintaining the structure and integrity of the linked list. Now let's talk about the head and the tail pointer. The head pointer refers to the first node in the linked list, while the tail pointer points to the last node of the linked list. These pointers are essential for efficiently traversing the list and performing various operations. With the head pointer, we can easily access the first node and start traversing the list by following the next pointers from one node to the another. Similarly, the tail pointer allows us to quickly access the last node, making operations like appending new nodes more efficiently. In our linked list class, we will maintain the both head and tail pointer to ensure efficient access and manipulation of our linked list. Next, we will cover the types of the linked list. So there are three types of linked list. One is singly linked list, second is doubly linked list, and third is circular linked list. As the name suggests, the singly linked list. It a singly linked list is the simplest form of the linked list. In an SLL, each node contains data and a pointer to the next node in the list. The last node's pointer typically points to the null, indicating the end of the list. Traversing an SLL is done in a forward direction, starting from head node. Single linked lists are also efficient when it comes to insertion and deletion at beginning or the middle of the list. However, they are less efficient for operations that require traversing the list in reverse or accessing nodes in reverse order. Talking about doubly linked list, a doubly linked list takes the concept of a singly linked list as a step further. In addition to the data, a pointer to the next node, each node in the DLL also contains a pointer to the previous node. This is the bidirectional linkage that allows traversal in both forward and backward direction very easily. Double linked list provides more flexibility compared to the single linked list. They allow efficient insertion and deletion at both ends of the list. However, the extra pointer per node consumes more memory compared to an SLL. Talking about the last type, circular linked list, the CLL is a variation where the last node's pointer back to the head node. It creates a loop. This loop forms a circular structure, hence the name is circular linked list. In the circular linked list, we have applications in situations where we need continuous cycling or when we want to efficiently traverse the list without reaching the end. To traverse a CLL, we start from the head node and continue until we encounter the head node again. Each type of linked list serves specific purposes based on the requirements of your program or problem at hand. It's essential to choose the appropriate type that best fits your need. Now we will cover the implementation of the linked list in Python. By creating a linked list class, we need to provide an example code snippet. Okay, so here is the output as well as the example uses. So I need to create a class for this to work well. So the given code demonstrates the uses of the linked list. It creates a linked list object called myLinkList and adds elements to it using the add at beginning and add at end methods, resulting in the list containing the values 10, 20, 30, and 40. The travels method is then used to print the values of the linked list, displaying 10, 20, 30, 40. Next, an element with a value of 25 is inserted at a position 2 using the function insert underscore at underscore position method. Then an element at the position 3 is deleted using the delete underscore add underscore position method. Finally, the traverse method is called again to print the modified linked list, resulting in the output with 10, 20, 25 as well as the 40. Now we can now we can run the code and create a linked list class, okay, by our own. In this following code, we need to create a linked list class. So for that, we need to create a class node. Sorry for that. Just commenting out the node class, and here it is. The class node def underscore underscore init underscore underscore self and passed very arguments is value. Self dot value equal to value and self dot next equal to none. This value is the number in the present in that node, the value of that node, and this self dot next is representing the reference pointer. Now we need to create a class linked list. In this class we need to add elements to the list. So we have two functions, add at beginning, add at end. So firstly, we have a function add at beginnings, self comma value. We need to create a new node, that is node on value. We need to create a new node dot next equal to self dot head, and we need to self dot head as a new node. So uh, this is the insertion of value as the first element. We need to insert the first element. We have to access this function. For onward insertion, we need to add at end. So for that, we need to create a new node. If it is not a head, we have to define self.head equal to new node, then current equal to self.head. And while current.next, we need to iterate it and current equal to current.next. And after closing the iteration, we need to assign current.next as new node. It might be confuseful, but when we run the code, it will be easy. For traversing the list, we have a function traverse, and for that we need to assign a head pointer as a current variable. While current, we need to print current.value, and after that we need to move to the next node. We can insert and delete also using insert function as well as the delete function. Here is the insert at position. We need to pass self comma value comma position, the value of the element at which we need to insert and the position at which we need to insert. Okay, so if position equal to 0, add at beginning. Else new node equal to node of value, we need to assign a head to the current, then this count equal to 0. While loop current and count is less than position minus 1. This is the logic we need to implement. Okay, after that we need, if a current is not of the current, then print position out of range. This is the uh, error handling. Then we need to assign new underscore node dot next equal to current dot next, and current dot next equal to new node. For deleting at a position, we need just a position. If head is not present, then list is empty. If position equal to 0, we have to say self dot head equal to self dot head dot next. Else current equal to self dot head, count equal to 0. While current and count is less than position minus 1, we have to write current equal to current dot next count plus 1. The same function we need to write in the insert. Okay, so we have to check it, and if not current or not current dot next, position out of range, and current dot next equal to current dot next, so it will be skipping the in between element. What is the meaning of the delete at position? It will be skip that position, and for the previous position it will connect the next position. So these are some example uses. So I have completed creating a linked list, adding elements, traversing the list, insertion and deletion. After that you can do these examples talking about advantages and disadvantages of linked list. There are few advantages and disadvantages. Dynamic dynamic size. Linked list can grow or shrink dynamically based on the number of elements. Efficient insertions and deletions. Adding or removing nodes can be done in constant time if the position is known. Disadvantages: sequential access. Linked lists have slower access times compared to arrays since elements must be traversed sequentially. Extra memory overhead. Linked list required additional memory to store the reference to the next node. Talking about the use cases and the application, storing and managing a large number of elements with dynamic sizes, implementing other data structures like stacks, queues, and hash tables, manipulating and representing data in graphs and trees. Talking about application of linked list, file systems and directory structures, implementing undo redo functionality in text editors, web browser, history management, representing polynomials in algebraic computations. Now, thank you for watching this comprehensive tutorial on implementing a linked list data structure in Python. I hope you found it informative and engaging. In this video, we explored the fundamental concept of linked list. which are crucial in understanding data structure and algorithm. So if you have any question or need further clarification on any topic covered in this video, please don't hesitate to leave a comment below. I will be more happy to assist you. Don't forget to subscribe to my channel for more tutorials on data structure, algorithm, and programming in Python. Thank you once again for joining me, and I look forward to seeing you in future videos. Happy coding!